In Lesson 4.4, Constant Rate of Change, you'll be identifying proportional and non-proportional linear relationships by finding a constant rate of change. The rate of change between any 2 points in a linear relationship is the same or constant. A linear relationship has a constant rate of change. Example 1. The balance in an account after several transactions is shown. Is the relationship between the balance and the number of transactions linear? If so, find the constant rate of change. If not, explain your reasoning. Well, from $170 to $140, it went down $30. It went down $30 over the course of 3 transactions because it went from 3 to 6, which was an increase of 3. And then from 140 to 110, that's another decrease of 30. Decrease of $30 over 3 transactions. And then from 110 to 80, another decrease of 30 over 3 transactions as well. So if we're looking for the relationship between the balance and the number of transactions, it's negative 30, or the change in the balance, over the change in the number of transactions. It's negative 30 over 3, negative 30 over 3, and negative 30 over 3. It is a constant rate of change, and that rate of change is negative 30 over 3, or negative $30 for 3 transactions. Which that works out to be negative $10 per transaction. It's negative 30 divided by 3 and divided by 3. That's going to be negative $10 per transaction. Or basically that means a $10 withdrawal per transaction. And yes, it would be linear because it's a constant rate of change. And that rate of change was negative $10 per transaction. You may want to pause the video and try the next 2 on your own. From 95 to 90, the temperature went down 5 degrees over the course of 5 minutes. And then it went from 90 to 86, it went down 4 degrees over 5 minutes time. From 10 to 15 is 5 minutes. And then 86 to 82, it decreased by 4 degrees again over 20 minutes. Or sorry, over 5 minutes time. So the rate of change between these 2 time periods is negative 5 degrees over 5 minutes. Then it was negative 4 degrees over 5 minutes and negative 4 over 5. That is not a constant rate of change, therefore it is not linear. The reason for that is it's not a constant rate of change. This one up here, I don't think I said it, but I should have said it is a linear relationship because it was a constant rate of change. Now let's go back here. From $8.50 to $17, that's an increase of $8.50. So an increase of $8.50. and it was an increase of 2 rolls of wrapping paper. And then from 17 to 25.50 was an increase of $8.50. And from 4 to 6 was an increase in 2 rolls of wrapping paper. And then $25.50 to $34 that was an increase of $8.50 for 2 rolls. So the rate of change is $8.50 per 2 rolls of wrapping paper, 850 over 2 and 850 over 2. That's a constant rate of change, so it is linear. And it's going to be $8.50 for 2 rolls. So if you break that down per roll, it's going to be $4.25 per roll. There's a constant rate of change of $4.25 per roll. Next, we're going to find a constant rate of change. We have an example with a graph, and it obviously is linear because it's a straight line. And so now we're going to just find what that constant rate of change is. We can do that by choosing any 2 points on the line and find the rate of change between them. So I'm going to go ahead and just choose this one right here and this one right here. If I write down 1 pizza is $3 and 3 pizzas is $9, the rate of change is the change in the price compared to the change in the number of pizzas. To go from 3 to 9, that increased by $6. And from 1 to 3, that was an increase of 2 pizzas. So the rate of change is 6 over 2, or $6 over 2 pizzas, which when you figure that out for 1 pizza, you're going to divide by 2, and you're going to get a rate of change of $3 per pizza. You may want to pause the video and try the next one on your own. Just find the constant rate of change for the time it takes to complete a highway trash pickup project for each number of volunteers in the graph shown. Interpret its meaning. So I'm going to just pick 2 points on my graph. I'm going to look for ones that are nice and easy for me to identify, like this one right here. 16 volunteers. It's going to take 60 minutes. And I'm going to choose this one right here as well. 32 volunteers is going to take, let's see, these are counting by tens, so this would be 30 minutes. So the minutes goes from 60 to 30, which is a decrease in 30 minutes, when the number of volunteers increases by 16. From 16 to 32 was an increase of 16. So the rate of change is negative 30 minutes, or a decrease in 30 minutes, per 16 volunteers. So now if we would figure this out for one volunteer, we'd want to divide by 16. So 30 divided by 16. That's a negative 1.875 minutes per volunteer, which would mean that it would go down 1.875 minutes per volunteer. The last thing we're going to do is identify proportional relationships. It says use the graph to determine if there is a proportional linear relationship between temperature on the Fahrenheit scale and temperature on the Celsius scale. So I've gone and I've just taken all of these data points, or some of them anyway, and put them into a table. So 0 degrees Celsius is 32 degrees Fahrenheit, 9 degrees Celsius is 37 degrees Fahrenheit, and so on. And now remember, to determine if something is proportional or not, you want to go ahead and look at the ratio. We're going to compare the ratio Now the one that we cannot compare is this one right here. We cannot compare when this is 0. So we're going to go ahead and move on and compare the other ones. 37 ninths. We're comparing Fahrenheit to Celsius. 42 eighteenths. And 47 27ths. And now if you want to compare those, it might be easiest to just change them to decimals to see if they're the same thing. 37 divided by 9 is 4.1 repeating. And then 42 divided by 18 is 2.3 repeating. And 47 divided by 27 is 1.740 repeating. These obviously are not the same thing. If you don't have the same ratio when comparing your two different quantities, then it is not proportional. You may want to pause the video and try the next one on your own. It says use the graph to determine if there's a proportional linear relationship between the weight of an object measured in pounds and the mass of the same object measured in kilograms. So I went ahead and took some data points from our line and made a table, weight and mass. Now when I compare these, I can't compare this one that has 0 for the weight in pounds, so I'm going to compare these ratios. I'm going to compare 9 to 20, 18 to 40, and 27 to 60. If I want to compare those three ratios, I can change them to decimals and see if they're the same. 9 divided by 20 is 45 hundredths. 18/40ths is 18 divided by 40, which is also 45/100ths. And then 27/60ths is 27 divided by 60, which is also 45/100ths. Since these three ratios are the same, that means it's going to be a proportional relationship. Now, what do you notice about the graph of a proportional relationship compared to a non-proportional relationship? This one was non-proportional, this one was proportional. Well, both of them are linear, but a proportional relationship always goes through the point 0, 0. You may want to add that little note to your notes. Proportional relationships always go through the point 0, 0.